So what is Orb Oracle? Orb Oracle, uh, this paper is by Bruno, Sarthak, me and Yuka. So yes, Orb Oracle is a platform where anyone can create your oracle with temporal string of values. So why it's needed? Like why Pith and Chainlink are traditional oracles are not sufficient. So suppose you have a new protocol and you launch a token. Now you want to have a price feed, so you have two options. Either you can operate your price feed by yourself, or you can ask Pith or Chainlink maybe to have your price feeds and on the same assets as you want, maybe you're sold to USD or you sold to INR. So it motivates the protocol and why we needed it. So why decentralized oracles? Why the oracles that are currently present are not sufficient, and the Pith and the Chainlink oracles and other oracles are decentralized, but the sources who are presenting the submitting the values maybe are not so much centralized. So that's why if you have a small company and maybe 10 people are presenting, submitting the prices, it's enough for you to have a good price feed. And the issue with today's price feeds are it's all incomplete and maybe fragile. And the major issue is like what the inactive sources also influence the prices very much. In our case, it has been handled with the delay theorem, and the theorem part is how now the main part is comes how our oracle works. So, in order to submit a value, you have to stake some tokens in the protocol, and then you have the permission to submit a token. So, and anyone can create an oracle like listing which token to be staked in order to submit a price. And when you have submitted any tokens in the vault, you are now eligible to submit the data values. So, the second part is submitting the data values. Anyone can go through the data part and submit the values. That can be handled by the aggregation part. With the formula you can see there, it incorporates the weightage of every submitter and the time it has been for the submitter, he has submitted the last value. And the reward distribution part is so in basic oracles there are nothing for the reward. They are working as long as they have some funding from the VCs or maybe until they are bootstrapped. And after that, mainly in the case of Milkomeda, it gets shut down as soon as the funding runs off. But in our case, whenever someone submits a price, he is rewarded with the amount of ETH or maybe ERC20 token that is currently in the vault. And where does that ERC20 token or ETH comes from? It comes from who are reading our price feeds. Mainly companies who want to integrate the Orb Oracle in their platform, or maybe some beginners who want to try to integrate the same Oracle in the price feed. And it will be governed by the protocol, the Oracle operators who are submitting the price. They can see who are reading the prices and are not contributing to the working of the Orb Oracle. And now the theorem part comes. I think Luca will explain it.
Can you hear me?
Yes. You can present your screen.
Yeah, okay.
Or should I do it?
No, it's okay, I got it. Okay, so the first theorem property of the Orb protocol is that it's called the inactive Oracle operator delay. So if an Oracle operator, so we have a set U of Oracle operators, and if one of the operators becomes inactive, so they stop submitting values, then their delay will converge to 0. So, like at first, it really doesn't. I found it confusing. I would have thought it would go to infinity because as time goes, the time just takes longer and longer because they're not actually submitting values. But intuitively, you can think of it as like if there is only a delay if they're still active. So if they're like, so in effect like alive, and if they're no longer submitting values, then they're like dead. So the delay should be non-existent. In order to prove the theorem, you define the Oracle operator delay, which is like the weighted sum of the current time minus the last time they submitted a value. And then the Oracle delay itself is just the sum of these delays for each operator. And this theorem is true as long as a subset of the operators remains active. Okay, I missed one by accident. So the second one is that the formula that we use for representing the weighted average of the price, the constant update rule that's used in this smart contract is equivalent to the sort of like explicit function, the ideal function. So on the left is the ideal decay weighting function, and on the right is the constant time update rule that's implemented in the smart contract. And you can show that these are equivalent by doing an induction on the number of updates. This is how we define the delay of the entire Oracle. So this sum is bounded above by the current time minus the like the time, basically the slowest or most delayed operator. Yeah, so the interval between data point submissions is only determined by the slowest Oracle operator. And you can do this just by applying the formula for the Oracle operator delay and then just simplifying until you get a bound. And it's minimum, so T star is defined as a minimum because the time keeps progressing forward. So current times are of larger values, right? So if an operator submitted a data point a long time ago, then that value of T is smaller. And the last theorem is the sustainable rewards property. So B sub oracle of tau means the balance of the oracle for a particular token tau. And it says that if it's positive initially, then it's always positive for all future times. And this comes from the fact that how we define the incentive for the oracle operator. And because alpha is between 0 and 1, then the new balance is always positive. So you can kind of it's like an induction basically. So it's going to be always positive for all future times. And this means that there's always an incentive for operators to assume new values, even though it's like really small. Yeah, that's it.
So one formula is remaining for the incentivize, which helps us to calculate like how much should we give to the submitter from the reward pool. Here you can see the beta is the parameter, alpha is the parameter which decides how much percentage of the reward that is currently in the contract is to be considered for the reward submissions, and others are the parameters that helps us decide how much time it's been there since the submitter last submitted our value to so that the submitter doesn't drain all the funds from the contract. That's why we have added a time parameter. It helps us to calculate like if submitter has submitted like 10 values in an hour, he should be paid less compared to the one submitter who has submitted after half an hour. So moving forward, why it's important to create a decentralized oracle, or why even oracle is such a big deal. So as you know, like oracle is a bridging point for every financial businesses and every protocols that want to get off-chain prices but on-chain. So they should be decentralized in order to make a protocol that is saying itself that they are decentralized, and depending on the oracle that is centralized. So it's important that the oracle also needs to be decentralized in order to keep the whole protocol decentralized. The future plans of our oracle includes maybe creating a poster for on every chain so that the submitter doesn't have to enter manually every values in 1 hour like 10 times. You can just run a Docker script in the background and it will do the work by itself. And the second part is composition of oracles. For example, you want sold by USD, and the oracles that are currently present are sold by INR and INR by USD. So you can divide both the oracles and get the sold by USD price. That's our future plans. Anyone can choose any number of oracles and do the composition. I guess it's the last try. Thank you. Any questions?
So, in this orb, the right is given to oracle holders, right? To token holders.
That one, yes.
Yeah, but then it's so you need for some initial bootstrapping, right? Like token sale.
No, like the oracle operator can simply create any ERC20 token and can distribute to the submitter's eTrust. So the price weightage is upon the how much tokens you hold. Like suppose you hold 100 tokens and if Bob holds 10 tokens, so Bob weight submission value will be less in deciding the final price of the oracle.
Okay, but then yeah, I mean it's called decentralized, but the biggest question here is how decentralized the initial token distribution, right? Because basically it defines the decentralization here. And yeah, in many cases practically it could be, so if it's token sale, it would be a oligarchic system probably.
Like tokens also can be listed on various exchanges, and anyone who want to submit a price can buy the tokens, can be the token submitter.
Yeah, on Ergo it could be the ERG token, for example.
Just native one.
You can choose, right? For example, in the case of, let's suppose that we would deploy a JED or Gluon stablecoin using Orb Oracles. What we could do is, for example, to give the right to every stablecoin and reserve coin holder to stake both stablecoins and reserve coins in a given proportion to mint the Oracle token, so that then the users themselves of the protocol could become Oracle operators. So that's one possibility as well.
But then
And even centralized oracles where there is just one token and one oracle operator who holds that token. So this kind of centralized oracle is also possible to be deployed with Orb. Yeah.
yeah, but if you have stable coin, right, which is using Orb Oracle, and you are basically distributing tokens to ones who lock stable
I
coins,
can't
then
hear you guys.
it's kind of Ouroboros, right? That could be
Yeah,
governance
so-
Ouroboros, so.
You can have the mic so Luca can also hear you.
Hey, so it's
Yeah,
I'm
like
not
for
sure
example,
it
if
is
you
the yeah,
let's say we take JED, right? And then we make JED use an Orb Oracle that where the token of the Orb Oracle is the stable coin of JED.
right. So you
Then
lock
this wouldn't be
JED.
good, right? Because the stablecoin holders would manipulate the price in their favor, and this would be bad for the reserve coin holders.
Yeah, so
And vice versa. If you made the reserve coins be the token of the Orb Oracle, the reserve coin holders would manipulate the price in their favor.
right, so there is some feedback loop here,
Yeah,
of,
so-
which is not looking good actually.
So the ideal in this case would be to give tokens not to just one of these two token holders, but to those who lock a certain amount of stable coins and reserve coins in a certain proportion, in such a way that they don't have an incentive to manipulate the price in any of the two directions.
Right.
Yeah.
So another option is to make a mineable token maybe, but yeah, it's hard to say.
To make what?
Mineable orb tokens. So you need to do proof of work to get orb tokens, but
Yeah.
then it's a bit hard to predict how those economies would work, right? When there are incentives to corrupt them, to corrupt Oracle economy, to profit from stablecoin protocols on top of it and so on. So yeah.
Yeah, so with Orb, we decided to leave it generic with respect to how you mint or mine or distribute the tokens.
Gotcha, but in
So-
practice, that's the most painful part.
Yeah. So I think maybe Anjali will talk a little bit about something related to that next, yeah, in the end of her talk, but without much details.
Oh,
Yeah,
okay.
yeah, okay.
Any more questions?
We have one more question. How did you deal with inactive operator when operator submit stop after long time?
Like there is a theorem also to prove the same. Like whenever the operators becomes inactive, so the tokens he has deposited first we use the amount of token he has deposited in the contract to determine how the price he has submitted should weight in the final aggregated price. But we also have a parameter delta t minus a t submitter. T submitter is the parameter like when the submitter has submitted the at last. So if you see delta t minus, if it becomes 0 comparatively because he becomes inactive, so then that the whole value will become nearly to 0 because it's 2 to the power minus. So it's divided by a large number. That's why.
Yeah, another comment about that. This delta that Sarthak was mentioning basically causes an exponential decay of the submitted values. So if an Oracle operator becomes inactive, we never delete the values that were submitted by that operator, but the values decay exponentially and eventually become negligible in the calculation of the average. Yeah.
So, Luca, thank you.
Okay.
Hi.
Thanks, Sarthak. Thanks, Luca.
I think we have completed the talk. You can leave.